Okay, so project 4, as I've mentioned, like to think of this as like the elective module. So therefore, you do have a choice to choose between one of 4 projects, all of which are on Learn. So all the prompts are on Learn. I think that is definitely something that's worthwhile reading through, especially if you can't decide which one you want to work on. So this is a different course. So if we go to mod 4, we can see our project prompt. So yeah, here you can see for each of the 4, there are links to the data sets all on this page. If you have any issues downloading the data, just let me know. I can do that for you as well. So basically there are 4 possible projects you can do in the order here. The first one is time series, recommendation system, image classification, or natural language processing. A couple things to keep in mind as you're trying to decide which one to do. A good thing to keep in mind, first of all, is I know it's not for another few weeks, but what is your capstone going to be? If you want to do something for your capstone, it might be a good idea to not do the same topic for your Mod 4 project, just so you can have something to contrast. On the other hand, to like contrast the point I just made, if you know that you're if you feel like a strong connection with one of these topics, you can do both. So for example, actually NLP is an example of a lot of people in my other cohort, they just finished their NLP projects and are doing another NLP capstone, because NLP, you can go a lot deeper. So if you have any thoughts about that, or if you're having trouble deciding between which one, let me know. If you're looking for straightforward, I think the most straightforward ones are actually like the recommendation system project, as well as image classification. Image classification, it says here, I think somewhere it says here that if you're having trouble choosing, choose image classification. It says that somewhere here. It's straightforward because there's not too much you have to do to set up. It's more of like evaluating your neural network and stuff like that. So image classification in terms of theory is the hardest one, but in like the actual coding part of it, it's the most straightforward. So those are just my 2 cents on if you want to get your project done quicker. But all right, let's talk about each of these. So for all the projects, I've linked here the setting up your repo link. So that's the same one that we'd be using for all the other projects. So it's the same. Other things to keep in mind this time, your data files are going to get bigger. So especially if you're doing the image project, or I think the recommendation system data set is also pretty big. But if you have any large files that are giving you GitHub issues, just throw the file name into your git ignore. If you need help with editing your git ignore, let me know. Also, something that with this cohort less so, but my other cohort, they struggle with coming up with business cases for their project. So don't forget, you still have to come up with a business case for this. And I'll talk about the business cases for each of the upcoming projects. But before I get into the guidelines for each project, does anyone have any like overall questions? All right. Let's start with recommendation systems, so that's one of the more straightforward ones. So with your recommendation systems, you start your notebook with your business case as usual. Obviously, your business case is to generate recommendations, but go another level deeper. Like, why specifically do you want to generate recommendations? How do you want to differentiate your project from other existing similar recommendations? Do you want to focus on customer retention? Stuff like that. Going one level deeper will make your conclusions more meaningful. And then also, if you have this deeper business case, as you're making decisions about your modeling, or about, maybe you want to subset your data in a specific way, the business case might play a part in your decision making there. So for recommendation systems, the EDA for rec systems is honestly pretty straightforward, because you just have user information and the movie information and ratings information. So things like, what is the average number of ratings per user, ratings per movie, what is the average rating overall, things like that. Or, what are you curious about in this data set? Maybe you want to see what the highest rated movies are, stuff like that. That's all for a game. So yeah, to confirm your popularity bias, just having a graph showing your highest rated movies is always a good idea. In this data set, there is another data file called movies.csv. And that one just has a lot of details about the movie, which doesn't go into our surprise SVD model, but feel free to use it for your EDA. When we get to the modeling portion of recommendation systems, first choose a baseline model. Within surprise, there are a lot of different models. Actually, let me pull it up real quick. Surprise. Oh, that was the first one earlier. Here we go. Within surprise, there's a lot of different models. So here, using prediction algorithms, you can see that they have a bunch of baseline algorithms. So this was one called KNN Basic. You can use that as your baseline. But yeah, you can see even within here, there is, let's see, is it here? Maybe it is here. There we go. Here we have KNN Basic. You have your SVD model. There's also different kinds of SVD models. So there's SVD++. This is a different kind of collaborative filtering model. So feel free to test all of these out. They all work in, I'm pretty sure all of these work in the exact same way. So yeah, pick one to be your baseline. Likely is going to be the baseline one. And then you will have your other models to compare to your baseline. Oh yeah.
Can you just add the link onto the page? So
that's a great idea. Yeah.
Hmm.
Pick your models from here. And then, oops. There we go. Thanks, Kishore. All right, so yeah, that's all within surprise. If you just use surprise for this project, you're all good, which makes it very simple because they all use the data the same way. And you wouldn't have to do too much like coding for each model as if you have a function to do all of it. As a level up, some people have tried to do this. You can try out Light FM, which is another library to incorporate your movie features. So here I've linked a couple walkthroughs on how to do that, but also happy to talk about it at one-on-ones or even during the office hours. So that's pretty much it for the recommendation system project in terms of the modelings on the modeling side. Of course, don't forget your metrics. You're going to look at your RMSE. Don't forget to interpret those. Let me just write that down. Interpret your metrics. Is it RMSE? I know that the one is also MAE, which stands for mean absolute error. So, all right. So after this modeling is done, think of your business recommendations. I know for projects that are so like singular purpose, like something like this, it's a little harder to come up with business recommendations, but maybe do a little bit of post-modeling EDA. You know, you have all of these predicted ratings. Are there subsets of movies that are getting higher predicted ratings? And then your recommendations, honestly, can be very similar to your phase one recommendations. And then as your final product or future work, are you able to generate ratings for a new user? In your Learn labs, there is a lab that actually provides you the code to generate ratings for a new user. So feel free to implement that or something very similar. And then, of course, throw out your ideas on how you think you could make this a more robust recommendation system. At this point,
one quick question. So
yeah.
Now, when you say that generate ratings for the new user, so
Yep.
is it like, okay, it's just like a pop-up that comes up, or it's like you're actually saying that you should be recommending, I mean, you should be rating this at 3 or 4 stars kind of?
So it comes from your model. And so by generating ratings, yes, basically, if you train your model, you can say for any user and any movie, what is the rating going to be? And so are you, more specifically, are you able to generate recommendations? So basically, you would have to do some coding of your own, or you can just repurpose the function that was given to you in the lab to be able to say, all right, for a specific user, this is what we predict their rating to be for all the movies. We're going to sort that and just recommend it the highest predictions.
So it's like, okay, before they are going to rate, you're going to predict and then compare their whatever you have predicted with their ratings, correct?
Kind of. For a new user, we would have to go back into like the cold start problem, if that sounds familiar. So this is the situation of like a brand new user, the way that the lab has it set up, which is honestly something that I do recommend following, is for a new user, you do something like what Netflix does. And what Netflix does is when you first join their platform, they'll just give you some popular movies to rate so that they can have some starting ratings to base recommendations off of. So that's how the function in the lab does it. You take in some brand new ratings and then you refit the model, and then you're able to generate recommendations off of that.
Okay.
Yeah, that's it for recommendation systems. Anyone else have any other questions regarding this project? All right, the next one is time series. So the business case here, you are trying to predict / forecast housing prices for zip codes. So naturally your business case will be around capitalizing on your predictions. So again, not too much depth with the recommendations here, but feel free to like come up with a more specific business case if you'd like. Something that I don't have here is that the prompt for the project, and I have talked about this with some of you, or where is it? Here. The prompt for the project here is, what are the top 5 best zip codes for us to invest in? In this data set, you are provided the historical month by month, I think it's median, is it median? Like the average price of a house being sold for every zip code over the past, I don't know, 10, 20 years. And then based on the data, you're supposed to narrow it down to 5. I'm telling you all that feel free to narrow down that scope. I think there's maybe about 200 zip codes in this data set. So feel free to honestly narrow it down to like 5 or 6 and then train models for those. And then out of the 5 or 6, end up with 1. If you want to do this method, by all means, I just think that it'll be a little bit much and your focus will more be on like adjusting model for different data. So I do recommend just like narrowing it down to fewer zip codes and then ending up with like 1 or maybe 2. So feel free to adjust this question.
Would you recommend like finding some sort of through line, like they're all next all adjacent zip codes or anything like that?
Yeah, it's good question. That is up to you and your business case. So I've seen it done where you're just picking zip codes in the same city, like adjacent zip codes, or in the same area. Also, something you can think about, like maybe you're targeting a specific kind of investor. Maybe they have like some sort of budget. So if they have a budget, then that will just narrow it down based on like the prices of the houses. So you could do that as well.
Okay, so you're saying either maybe geography, or maybe these are the 6 most expensive or the 6 middle class or whatever, and find some sort of similarity and use those as well.
That's right. The method in which you choose to subset your zip codes, as long as you have some sort of like backstory for that, it's fine by me.
Okay.
Awesome. Anything else about like this setup of the problem?
So can it be just like, okay, a specific location, I say like, okay, I'm going to target, right? One of the, like, let's say I'm going to target somebody from Michigan.
Mm-hmm.
And within Michigan, I say that these are the 5 zip codes where you should be investing. And the reason is whatever reasons comes up.
Yeah, so if you're trying to narrow it down by a place, I would start with like, for example, let's say in Michigan, in this data set, I'm not sure of the actual number, but let's say in Michigan, let's say in Michigan, there's 10 zip codes. The idea is, again, depending on your business case, how much you want to narrow it down. The whole point of this is to see like, can you use forecast information and turn that into an actionable conclusion? So if you want to go from like 10 zip codes and you want to narrow it down to like the 3 most profitable ones, like the most profitable ones in like 1 year in the future, do that. I think most people start with like about 5 and then narrow it down to 1, just because that's like, I would say like the modeling process is fairly repetitive, but you end up with different like parameters for each zip code. So because of that, you don't, I think it makes more sense to focus on fewer, but try at least 4 zip codes. Does that help? Cool. Anything else? I know this is like kind of like a wonky prompt because I'm giving you all like space to move, so feel free to clarify anything. All right, so okay, let's go back to this. Yeah, your business case will be around capitalizing on your predictions. However, whatever the scale of that is, up to you to define. So in terms of EDA, you are analyzing time series data for multiple zip codes. How can you make your EDA most efficient so you're not doing one EDA for every zip code? Honestly, just like looping your functions, make it such that there's not redundant code. That's what I mean by that. So instead of this, make sure there's as little code redundancy as possible. Okay. Your typical time series EDA, check for your stationarity and seasonality, your like ACF, PACF plots. And then after you're done with your modeling, to add on to your EDA, if you want to add exogenous data, you can do that. And you probably want to do some EDA on your exogenous data that you're going to feed in. So EDA for time series, those processes are, I think, pretty clearly outlined in the labs. So not too much there. Now for modeling, first, before you even start modeling, think about your train test split. With time series, your train test split can be a little bit more flexible. So for example, with any time series model, the same model, the further into the future you're going to, it likely is going to lose predictive power. So think about what kind of time frame you're trying to forecast for investors. If you're looking for like a 1-year turnaround, your train test split can honestly just have like 12 data points in the last 12 data points. The last 12 data points can be your test set rather than doing like a 20% split. So there is flexibility there. Also, each zip code does have a different number of points. So take note of that and you can definitely adjust accordingly. With this modeling process, definitely start with a baseline as usual. This can be like maybe like just an AR model, just an MA model, perhaps just a straight line. That can also be a thing. And then after that, you just want to start with your traditional time series models. So yeah, the point here is whether you create a single model for all zip codes or create multiple models, it is important to demonstrate your ability to work with these ARIMA-like models. So basically, you're going to end up running an ARIMA model for every zip code in the subset of zip codes that you're choosing for your project. So there's ARIMA models that we've talked about in time series study groups, but also there's auto ARIMA that I think would be really, really helpful for this project. Auto ARIMA, and here I've actually linked a walkthrough. Auto ARIMA is basically automated grid search for, grid search is automated, but it's grid search for your ARIMA models. So picking your PD and Q values. So of course you will have to still give it the range of PD Qs that you want it to use, but that should come from your EDA. So find a way to like, if you can automate this process, that's great. But auto ARIMA is just a suggestion. I think that will make the project a lot more streamlined. So there are many ways to determine the top zip codes. Is it purely based on like, the percent change in the next year, or is it determined by like, low RMSE because you want it to be reliable? So it's important to document your thought processes and back up your modeling decisions. This is, again, another very straightforward project. You're just running, the requirement is that you at least run ARIMA models. As a level up, I talked about the fact that in the appendix section, there is a Facebook profit model. Feel free to try implementing that. The groups that did in my other cohort is very plug and play. You really just plug in your data and then take a look at the results. So could be cool to see how that one performs versus your ARIMA models. Now in your business recommendations, I would say like, because of the narrow scope of this project where the prompt is to just recommend zip codes, your recommendations will obviously include what zip codes to invest in, but it's important to address your caveats. So for example, if you're recommending, all right, zip code 1, 2, 3, 4, 5 is what I recommend based on my project. Do talk about what are potential drawbacks. As with like traditional ARIMA, models, these are very, very sensitive to shocks, for example. So definitely you want to talk about, if you're trying to pitch a zip code for people to invest in, what are some things that they should be aware of going off of your recommendation? And then, yeah, if you include exogenous variables, which is not a necessity, your recommendations can be derived from coefficients. Any questions regarding the time series project?
I have one question. So now you were saying that like, okay, we just use the last 12 data points for. Now what happens like if the train test split is right, the difference is very high. For example, it's reversed, even not even high. It's like the testing data is higher than the training data. In that case, what happens?
By higher, you mean the error?
Yeah. So now if I say that I'm going to train on, let's say, 20% of the data and 80% of the data is going to be the test.
You definitely don't want to do that. You always want to have more training than testing. Usually when I talk about flexibility here is that you can be flexible in making your test size smaller.
Okay, so the smaller the test size, the better the result.
I mean, not necessarily better, just the smaller the test size, the more recent information your model has when it's training. So because train test split in time series is usually like by a cutoff time, let's say we do like let's say we do an 80-20 train test split. An 80-20 train test split, I know in some of the zip codes, and this is why I actually say that you can be more flexible. The 80-20 split for some zip codes puts the split right at 2009, 2010. And you think about it, if you're trying to make predictions for now in like 2021, how reliable is that forecast going to be if the data is from like 2010, especially since that was when there was like a financial crisis and all the housing prices were going down. So based on that, the less in the past your training data can be, the more reliable it'll be for forecasting.
So if I find that, okay, there are like more data, which is right on the thing, it's like most of the data which is available on that zip code is only during the first 10 years and the recent data are not available. In that case, the prediction will never be going to be, very close to accurate, correct?
Yes, in that scenario, that is true. Good thing is, in this data set, the missing data is all from the past. So you definitely have the most recent ones, though it's just like some zip codes, they only started collecting data later.
Oh, okay.
Yeah, so we won't be in that situation, luckily. Cool. Anything else?
Yeah, I have another question. So I know this data set's a little bit old. So because it's old and you're forecasting, is there a way to check it? Like, can you find the more recent data and say, oh, how did my predictions do?
Yeah, you can actually find the data on Zillow's on that link where they link in the prompt. You can actually look up through Zillow research, you can actually find that data.
So you can check it again and see how good your predictions did. Okay.
Yep, but also something that you can definitely do in this project is you can be in the scenario, like imagine you're an investor in 2017 or something like that. You can definitely place yourself a few years back based on this data.
So and then see how you would have done.
Yeah. Cool. Anything else before I move on to the next one? All right, so the next one we're going to talk about is the NLP project. So for the NLP project, the prompt, basically you have a lot of tweet data. All this tweet data was collected at South by Southwest, which is a conference, a tech conference. And this data is, I think, like a good 10 years ago. And basically you have people's sentiments on the new Apple and Google products that were being introduced during that time. And so the project prompt here is to see if you can predict sentiment of a tweet, like whether the tweet is talking positively or negatively about whatever it is it's talking about. So all of the tweets are already labeled. You just have to build a classification model that's able to detect whether something will be positive or negative. So business case, I feel like you can be a little bit more flexible here. What are you doing this NLP analysis for? It is mostly Apple and Google products, so maybe you are like some sort of consultant for them. Maybe you just want to be able to see what people liked and didn't like about products, stuff like that. I think this one's pretty flexible to come up with the business case. So EDA, at its core, this project is still a classification project. It is a supervised learning classification project. The data is just text. So the same thing still stands. Your EDA still should be comparative to aid in your modeling. So like I told you all before with the last project, here our classes are going to be positive and negative. There's also actually a neutral class. So this is actually like a multi-class problem. But between your like positive tweets and negative tweets, what are the most common words in each class? So your EDA should be comparative because that will help you make decisions when you're modeling. A very, very common EDA for words is word clouds. If word clouds is the only EDA in your notebook, that is not okay. Because word clouds are, I mean, yes, you can see based on the size of the words, but you don't have much, you don't have scale attached to it. So if you're doing word clouds, sure, use that for the presentation, but I do want to see quantitative equivalents. So literally like a bar graph of the exact word counts along with your word cloud. So yeah, in terms of EDA, just think about, if you're presented with this group of tweets, what do you want to know about it? You want to know common words? I think that's a given. Maybe as part of the data set, they also tag like whether it's talking about Apple products or Google products. So maybe you want to look at it on that front, even though that's not the main thing you're classifying. So here there's like definitely a lot to play around with in terms of what you want to do your EDA on. In terms of that, if you want to level up your EDA, clustering is definitely your approach. So within clustering, LDA, which if you remember, I shared that at the end of my second NLP study group, is the one with like the interactive, they're like the bubbles and they tell you like what topics the tweets are talking about. So yeah, feel free to do that as well if you want to level up your EDA. Not necessary though for this project. For this project, there are several different approaches you can take. Two things you can focus on, either the NLP pre-processing or the modeling. I will say if you're choosing to take the modeling approach, it's very, very similar to the last project. So only I feel like if you're really like shorter in time or if you feel like you still need to catch up a lot, then I would say to do the modeling approach. If not, I highly recommend if you're doing the NLP project to focus on the pre-processing approach. So I'll talk about the pre-processing approach first. So we've talked about a bunch of pre-processing techniques, count vectorizing, TF-IDF, and word embeddings being three of them. Try different pre-processing techniques and see how that data plays with the model. So maybe with like count vectorizing, your model gets like 60% accuracy, but if you use TF-IDF, maybe it goes up to 70. So this is what you'll be testing. With this approach, you don't have to do as many models. I think like 1 to 2 is enough. I usually like to do like naive Bayes because it's fast and works well in text data usually, but also decision, like some sort of tree model, whether it's like a decision tree or an ensemble tree model, just so you can get feature importances, because feature importances is good to use for coming up with conclusions. So with this approach, you're more likely going to be having a bunch of different data frames that you're going to feed into the same models, that you're going to fit onto the same models. Any questions about that? It's a slightly different take from what we've been doing. Like the last project, we had the same data on many different models, but now we have different kinds of data or different representations of our text data that will go into similar models. Questions about this? All right, so instead of doing the pre-processing approach, if you feel maybe like not super comfortable with the last project, by all means, feel free to do the modeling approach. And for that, you can just pick one of the pre-processing methods and then do the same processes as the last project. So just throw your data into like 7 or 8 models, and then just pick your model based on that. Something else you can do, post-modeling EDA, maybe based on your most important features, that we also talked about last time. Cool. So in terms of your business recommendations, draw your recommendations from your models. What words led to classifying your sentiment as positive or negative? And also perhaps how can companies adapt with this model to better serve their customers? That's a common approach that people take with this because it's talking about like Apple, Google products. So if you're seeing like specific patterns coming up where people keep talking about, I don't know, maybe like their iPad's battery life is really awful. If you find that to be a pattern in your data, you can talk about it as a recommendation. Cool. With this project, any questions? All right. So the last one is image classification. I will say like the image classification process, I think as I mentioned before, in terms of like the theory that goes on with the neural networks, that's probably the toughest project. But in terms of like the coding, it's the lightest one because, and you'll sort of see why. So business case in classification, especially with image classification, the business case will lie in the task itself. You just want to be able to detect abnormalities in chest x-rays. So this data set is going to be a bunch of chest x-rays and you're trying to see if there is pneumonia or not based on a chest x-ray. So I think based on the EDA that I've seen, if like the chest x-ray is like more cloudy, then you have pneumonia. If it's not, then it's not. So yeah, you're going to build a neural network to be able to detect that. So in terms of EDA, there's not much EDA you can do with just images. So as I say here, definitely harder for images. So do as much of a summary as possible in this section. Maybe output a couple images from each class as examples. Let's maybe see like your class balance. Let me just put that down. Your class balance, stuff like that. And pretty much that section will be done pretty quickly. So with modeling for this project, definitely start with a baseline model. It can be a very, very simple neural network. It can be even like a traditional machine learning model. It doesn't have to be a neural network, but whatever you decide, just have a baseline. So yeah, it's up to you to decide. It can be a single layer network. You can even use some scikit model. For this project, you can definitely experiment with different neural network structures. We've talked about a couple of the layers earlier this week as well as last week. We have the dense layers. On Monday, we talked about convolutional layers and pooling layers. So play around with that. I've also in those notebooks have a lot of like walkthroughs. So feel free to adapt some of the structures that they're using. Yeah, but convolutional layers are not required. To level up, all of these things I'm actually going to talk about on Tuesday on our next study group. So pre-trained networks, intermediate layers, dealing with potential class imbalances. I'll talk about this on Tuesday. So right now, but basically these are just other techniques that you can use to upgrade your neural network. In this project, definitely includes some tuning of your neural network. On Tuesday as well, I'll talk about how you can do grid search on your neural network. So definitely incorporate that, or you can also just manually change different parameters. I'd like to see at least 4 different neural networks being trained. By 4 different models, I really am quite lax with the definition of 4 different models, just because every model with other students' experiences, I know each model does take about 2 hours to train. So I'm not expecting you all to like run it over and over and over again. Just each neural network should have like a key difference about it, and then that just counts as a new model. So while making changes to your model, do document why you're making this change. Maybe you're literally just testing out a hypothesis of like, maybe you want to just see if this activation function works better than ReLU, for example, and also what your hypotheses are so that you can, confirm or reject your hypotheses later. With the neural network, recommendations can definitely be more qualitative or general, just because you cannot do any sort of coefficient analysis. And again, the black box nature of it makes it hard to find any meaningful inferential information. You could potentially talk about model architecture in your recommendations. Maybe you can say like, oh, with this limitation of time, I didn't have time to try this in my model that you maybe wanted to. Oh yeah, and also there's this library that you can overlay a heat map to find out the most important pixels per each image. That's just something that you can do. But I think everybody here, no one is doing a neural network project. So yeah, but any questions on this project?
Just one, like, so how many images do we need to, if we work on, let's say 10, 15?
You definitely want to have at least 1,000 per class, 1,000 images per class. So yeah, the data set can be very heavy. Yeah, most students, actually not most, but some students have decided to move all of their work onto Google Colab. And if you are looking to do that, let me know so I can talk through like how you can set that up.
So now these all these images are already available, or we need to?
Yeah, all the images are already available over, let's see. Nope, this is the NLP one. Here we go. So you can get this off of Kaggle and they allow you to just download it, the 2 gigabytes of data. And I guess you can see here, that's what your EDA will look like. Cool.
So I mean, just for my understanding, like, let's say if we pick up, let's say 5 images and we give it a model saying that if the image looks like this, right, which is darker in color, or let's say because it's black and white, so it's either the darkness which takes care of because of the cloud, right? If we say that in this every section, so we select the center grid where the ribs are, and say that within this ribs, if you find dark cloud, it is pneumonia based, and if it is lighter, then it is non. And
That's right.
based on that, like we say that, okay, then we have to run all the other images, or let's say select certain images to run and select which one has and which one doesn't have. That's what the prediction will look like, correct?
Yeah, so the way after you train the neural network, you'll be able to feed it in any X-ray image, and it will, based on the composition of the image, whatever the pixels are, it will be able to tell you whether it's likely to have pneumonia or not.
And in the core lab, like let's say if we put this data on, we have to put it on a drive there.
Yep.
I'm not sure whether 2 GB is available. 15 GB.
Yeah, the limit for Google Drive is 15 gigabytes. So yeah.
So possibly the entire. So the data itself is 2 GB. So like when we run more, the size of the entire model will go around.
Not that much.
Not that
it won't
much?
be that much. Yeah, the models themselves will take up like less than 100 megabytes.
Okay.
Yeah.
Okay, let's see.
Anything else regarding this project, or at this point, any of the projects?
Yeah, I have another question. So the first part of this mod, we did principal component analysis, clustering, big data. Are any of those going to be part of these projects?
Not necessary. Big data, definitely not. You can definitely find a way to incorporate clustering and PCA into it. Probably not the time series project, honestly, because you only have like one variable that you're using. So probably not the time series one, but for NLP, you can definitely use clustering and PCA. For recommendation systems, you can as well, using like the movies data. You can technically do the same with image data, but yeah, not time series just because there's just one variable. But it's not a necessity to incorporate those things into this project.
Okay.
I'm also happy to talk about, if you do want to incorporate some of these things, how you could. Cool. There are a bunch of questions and answers here. This is from my last cohort that went through this project. So these are the questions that actually came from the cohort whose presentations I just sent over to you. So feel free to consult this. A lot of this is stuff that I will likely also go over during office hours. So in terms of timeline, you technically have 3 weeks for this project. So this project is only due on March the 8th. So on March the 8th, we'll do our presentation, and that's because we have the regular 2 weeks to do the project, and then we have the 1 break week after that. Do keep in mind that after the break week, we get straight into capstones. So I do recommend to because these projects are more straightforward, get it done with so you can have time to take a break before capstone, because usually that's when this is the time when burnout starts to happen. So that's my advice. But yeah, the project's not due until March the 8th. So you do have some time. In terms of office hours, next week it'll be on Tuesday and Thursday because President's Day is on Monday. So I'll be wrapping up neural networks on Tuesday, and then on Thursday we'll have an office hour where I can talk through some of these questions. And then the following week, Monday and Thursday, back to normal, again, taking questions too.
One quick question. So this particular image classification project, can it be on the capstone, or it's altogether a different thing that needs to be done?
So for the capstone, one requirement is you cannot use a data set that's readily available. So you can do another image classification project, but you would have to get your data on your own. It cannot be something off of Kaggle. And there are ways to scrape images and stuff like that, which I'll talk about, which I'll talk about when we get to capstone. But yeah, if you want to do image classification project for capstone, you cannot use this data set, but you can do the similar project.
So it's like it either has to be pulled through the
API.
Yeah. And so most of them will be because and pulling through the API. Otherwise, downloading 2 GB of data won't be available anywhere. Correct?
Yeah, yeah, you can also I've had students web scrape. So I've had students actually web scrape Google image searches. So that's also a possibility. But yeah.
Okay.
Cool. Anything else? All right. So to drive the upcoming office hours, on Tuesday, I don't think that my neural networks will take on the whole take up the whole hour. So I'm happy to take questions on Tuesday as well as you're getting started. But if there's anything here that you think needs more explanation, let me know, because I can use your feedback to drive the office hour. So I'm not just reading through this, because that's probably what I'll end up doing. So yeah, feel free to let me know what difficulties you're facing, what you're working on. This project, I do recommend that students take it easy for this project as you ramp up to the capstone. So yeah, keep that in mind too. All right. I don't think I have anything else for you all. Are there any final questions before we close out? Awesome. Sounds good. In that case, I will see you all back here on Tuesday. Don't forget, not Monday. And then, yeah, as usual, anything you all need, just let me know. All right. Have a good night, everybody.
Everyone.
Good
Have a
night.
good weekend.
Yeah.
Bye.